Assalamualaikum warahmatullahi wabarakatuh and hi everyone. I am Muhammad Faris Ezwan Bin Mohd from Department of Chemistry of Faculty of Science, University Technology Malaysia. Today I would like to present my final year project which is electrochemical studies on bimetallic composing oxides with activated carbon for enhanced supercapacitors. So this project was supervised by chemist Dr. Muhammad Amirul Aizat bin Muhammad Abdah. Okay, first of all I would like to go for the introduction part first. Okay, for this parts, so the rising demand for sustainable energy has led to the search for the efficient energy storage systems that are eco-friendly. So traditional batteries such as lithium-ion batteries, while widely used, suffers from such as limited raw materials, short lifespan, and environmental risk. So, because of that, supercapacitors have gained attention as an alternative because they offer high power output, fast charge and discharge rates, and long cycle life, which making them suitable for application like electrical recycles, renewable energy storage, and so on. So they are broadly classified into three types of supercapacitor, which is EDLC, pseudocapacitors, and hybrid supercapacitors. So in my project, I will conduct the hybrid supercapacitors. So we go for the methodology part first. So for this parts, it shows that there are three main points that I would like to highlight here, which is the first one is the synthesis of bimetallic CZO, which is represents copper zinc oxides. So in this process, I use copper nitrate trihydrate and zinc sulfate hexahydrate as my precursors. So these two precursors were mixed with the presence of urea and deionized water and put it on the autoclave to undergo the hydrothermal process, which is use the temperature around 120 degrees Celsius. And after that, the sample was undergo the calcination process, which is around the temperature for 400 degrees Celsius. And after that, I conduct the slurry preparation, which is the mixture of copper CZOAC, which is copper zinc oxide with the activated carbon, for stirred with the presence of binder and the solvents. So I prepare for different ratio, which is 100 0, 90 10, 80 20, and 70 30, which is consists of ratio of bimetallic CZO and activated carbon. So this mixtures was stirred with the presence of binder and also solvent, which is I use PVDF binder and also NMP solvent. And this slurry was prepared around overnight. And after that, I conduct the coating process, which is the prepared slurry was coated onto the aluminum foil to make it as a working electrode. So here's the part of my methodology part. So we go for the result and my electrochemical performance results, which is there are four different graphs, which is the first graph, the top left one is the CV analysis for different ratio of bimetallic composite oxide with activated carbon. So based on this graph, it shows that 80-20 ratio shows the large enclosed area, which is will lead to the high theoretical specific capacitance. So after that, I choose 80-20 ratio to run for another CV analysis at different scan rates. So from at the top right one, we can see that as the scan rate increase, the the graph becomes smaller, more even smaller, which is shows the at the lowest scan rate, it shows the bimetallic composite oxide with activated carbon shows the high specific capacitance. So when we refer to the top left graph, which is scan rate over specific capacitance, it shows that at the lowest scan rate, which is 5 millivolt per second, it shows the highest specific capacitance compared to the other ratio. So we can see the trend is like the increase the scan rate will lead to the decreasing of a specific capacitance value. So after that, I run for the GCD analysis, which is for the third graph for four different ratio also, and this graph was conducted to see which ratio shows the charge longest charge discharge times. So based on this graph, it shows that the 80-20 ratio still shows the longest charge discharge time, which is will contribute to the increasing performance of electrochemical supercapacitors, which because higher just discharge time will lead to the longest to the highest specific capacitance and also higher energy specific energy that can be stored for that supercapacitor. So here for the second table, you can see that a 80-20 ratio still shows the highest specific capacitance and highest energy density for for the for electrochemical performance of supercapacitors. So because of that, I conduct the third analysis, which is the EIS analysis, which is to see the resistance that produced by the four different ratio. So based on the fourth graph, which is negative Z ohms over Z ohm, Z not ohm, you can see that the 80-30 ratio still shows the lower resistance that consists of RCT and ESR resistance. So based on this graph, it can be seen that 80-20 ratio shows the lowest resistance, which is will increase the ion diffusion uh, that produced from the pseudocapacitors, which is the bimetallic composite oxides, to enter the porous structure of EDLC, which is activated carbon. So because of that, it can be concluded that 80-20 ratios is the best ratio for the determining the best ratio for electrochemical performance of supercapacitors. So after I conduct this analysis, I come out with the three different conclusion, which is the first one is material development, which is the bimetallic composite oxide was successfully synthesized using the hydrothermal and calcination method and effectively combined with the activated carbon through physical mixing to form the composite electrode material. So the second one is structural and morphological properties, which is SRD, SEM, and FTIR was confirmed the formation of crystalline sample faces, porous carbon structure, and good morphological integration between CZO and AC, which is validating the structural integrity of the composites. So the last one is synergetic effect, which is the CZO AC 8020, as we discussed in the previous now, shows the highest specific capacitance, which is 994.02 Fahrenheit per gram by CV, and also 375.5 Fahrenheit per gram by GCD. And it also shows the low charge resistance RCT value of 3.49 ohm and superior energy and power densities. So based on this conclusion was actually aligned with my three different objectives. So the last one is acknowledgement, which is I would like to express my deepest gratitude to my supervisor, which is chemist Dr. Muhammad Abdul Arizan, for his continuous guidance, encouragement, and insightful feedback throughout the course of this project. Also, his expertise and supports have been invaluable to the successful completion of this work. Also, I want to give credit to Jia Xiaoli, which is Dr. Aizat postgraduate students, for her helpful advice and constructive suggestion support, which greatly contribute to the development of this study. So here is the last one is the my abstract, which is the I conclude all the things from introduction into conclusion, which is the increasing demand for efficient and eco-friendly energy storage has drawn attention for two supercapacitors, known for their high power densities, fast charge discharge rate, and long life cycle. So this study explores the development of composite electrodes using bimetallic CZO and with combination of activated carbon AC to enhance the supercapacitor performance. So CZO was synthesized using the hydrothermal method following the calcination, and AC was prepared through the chemical activation using KOH. So after that, the sample was undergo hydrothermal and calcination technique, and the sample was undergo the FTIR, SRD, and SEM first to determine the morphological and the characteristic of my sample. And after that, I run the CV, DCD, and EIS to determine the electrochemical performance of supercapacitors with four different ratio. So I think that's all from me. Thank you.